All right, we're going to start with a cone here as the next three-dimensional shape that we're going to look at. And a cone is provided on the formula sheet. So V equals 1/3 pi r squared h. Okay, so here we go. Volume is 1/3 pi r squared h. Now a cone looks just like a traffic cone, okay, although it does have a point at the top. Okay, so, but we have our cone, and the base of a cone is a circle. Now, there is no capital B here, it's not that kind of base, but the base is a circle. And if you look at this formula here, we can actually see the pi r squared, which is the area of a circle formula, appear in this shape. So we are going to need to know what the radius is. We're also going to need to know the height of the cone. Okay, that's going to be another important number for us. So the height of the cone is going to be valuable. And then this 1/3 just comes from the taper of the cone. The fact that we're not actually finding a cylinder, if you remember the volume of a cylinder formula was pi r squared h, you'll notice we have 1/3 pi r squared h is our formula here. So that's going to be very important for us to also note. Okay, again, all we're doing is finding the values and plugging in. So if I take a look here at what we've got, if we come up with a cone, okay, there's our slightly rounded bottom. And let's add some values to it. Okay, so if I tell you that the height is 20, let's go 20. And if I tell you that the radius is 6, okay, then we're going to go find our volume. So volume is going to be equal to 1/3 pi r squared h. Just like the last video, we're going to ask for it in terms of pi. Okay, so 1/3 pi r squared h. Our volume is going to be 1/3 pi. Our radius is 6 squared, and then h is 20. I am going to be plugging the 1/3 into the calculator, the 6 squared into the calculator, and the 20 into the calculator. I'm leaving it in terms of pi. So my volume here is going to be, let's quickly plug that into the calculator. I've got 1/3, I've got 6 squared, and I've got 20. And that comes out to 240 pi. Okay, so there's our volume of a cone. That's a lot of this is just plugging in. One of the reasons I picked these topics for us to do some remote learning with, because it really is just seeing, oh, let me go find the formula, let me plug in. It really does become that kind of repetition. And then the final shape that we're going to be looking at is a pyramid. Okay, so a pyramid can be somewhat different. So when we scroll back up, we're going to see the volume formula of a pyramid is 1/3 capital B H. So the volume of a pyramid is 1/3 capital B H. And that B does again stand for the area of the base. Okay, and we can see a variety of bases. We're going to see triangular pyramids where the base is a triangle. We're going to see square pyramids where the base is a square. You could see a rectangular pyramid where the base is a rectangle. You could see really just pretty much any shape as the base of a pyramid. So drawing a pyramid can be kind of tricky, but let's just kind of show you. So let's say it was a square base pyramid. Then all of my points are coming up to that point there. If we have a triangular base pyramid, okay, we're going to be looking at a triangle. And then if our point is over here, all of our points are headed up to that point there, okay? So the pyramids in Gaza, for example, that you learned about in history in Egypt, those are going to mostly be square-based pyramids, okay? But we do have other type of pyramids, and that's why they give us this general B for the formula. Now, what's nice is if you remember, if we're dealing with a square-based pyramid, then B is just equal to side squared because it is a square, so all four sides are the same. We learned that in our quadrilaterals unit. If we're talking about a triangle as the base, the triangle is going to have a base of 1/2 lowercase b times h, which is 1/2 base times height. Okay, and you'll have to pick a base side of your pyramid and have a height. Now, this information will all be provided to you. This lowercase h, so it's important to note if we're talking about a triangular base pyramid, that this h and this h are going to be different. Okay, one is the height of the pyramid, one is the height of the base. So just be careful with that. Okay, that's one place where it can get kind of tricky. So let's take a look at a pyramid and let's try and find the volume of it. Okay, so there's our pyramid, and I'm going to go throw in some numbers. I'm going to tell you that to the center, that number's 10, and I'm going to tell you that each side is 4. Okay, so we know that we're dealing with a square-based pyramid here. So our volume formula is going to be 1/3 base times height. Now you'll notice there's no pi in this formula here. Kind of interesting, right? Generally, we're only going to see pi in things that are round. Okay, you'll notice that triangular prism had no pi in it. You'll notice that our rectangular prism had no pi in the answer. Okay, so a couple of different things that you might want to notice here might kind of jump out at you. So volume is 1/3 base times height. So for us, our base is going to be side squared. So 4 squared, that gives us 16. Okay, and that is our base there. So now our volume is going to be 1/3 times 16 times the height. The height is 10. We're going to plug all of this into our calculator, and we're going to get a fraction. I'm going to leave it as a fraction, okay? 160/3, but if you were to plug into the calculator, you would get 53.3, where that 3 is repeating, okay? And there's just too many examples to go through all of them with the pyramid, but what's really changing is that b, the area of the base. So watch out for that, right? As the area of the base changes, that's something you want to just be on the lookout for, okay? So hopefully one that helps a little bit, kind of show you the different 3D objects we're going to be going through. In addition to these videos, I will be posting a couple of questions for you to work on. I think with everything we've gone through today, this will probably end up being a little bit of a multi-day lesson. Okay, so however you want to approach this, but you know, this is a good, you know, part to learn at home, because a lot of this is just simply plugging into a formula. So I'll be available via the Google Classroom to answer any questions that you have. But I encourage you to watch these videos. I encourage you to take notes, just like as if you were in class. Kind of write this down. I know it's on the screen in front of you, but in your notebook, take these notes down as if you were going through it. If you have to pause the video at times, pause the video. Okay, work at your speed. This is, you know, we've said it a million times, but this is uncharted waters. So you have to learn how you learn remotely now. And that's going to be something you see more and more of, I think, as we go through classes. So hopefully this makes sense to you. And if you have any questions, please feel free to reach out.